Today we're going to begin our discussion of the library functions. This first video we'll be talking about linear functions. A linear function is a function of the form f of x equals mx plus b, where m is your slope and b is your y-intercept. The graph of a linear function is always a line. Here's a picture of the line. In this case, my y-intercept is 1. That's where it crosses the y-axis. And the slope, rise over run, is also 1 because I can go up 1 and to the right 1, or up 2 and to the right 2. 2 over 2 is still 1, so it doesn't matter which way I do that. Some of the properties of this linear function, the first one we're going to talk about is the domain. The domain are all the allowable x's. If I look at my x-axis, I can pick any x I want, and I will be able to find a corresponding y value that touches the graph. So here if I go to -3, I can come down and see that the corresponding y value is -2. Here at the x value 0, the corresponding y value is 1. If I go to 3, the corresponding y value is 4. If I came all the way over here to 6, I could still find a corresponding y value. I just might not be able to tell what it is because my graph doesn't extend that far. But this line will extend to infinity. So I know at 6, I am going to come up here and touch the graph and find a corresponding y value if I extended my line. The next property is the range. For the range, I'm going to be looking at the y values that come out of the function. So I'm going to be looking at my y-axis in this case. So if I look right here at my y-axis, I can pick any y that I want and I'll be able to find a corresponding x value anywhere that I want. So 0 here, the corresponding x value is -1. Here at y equals 2, the corresponding x value is 1. I could go way up here and still find a corresponding x value. So I'm allowed to get any of these values to come out of my function. So the range then is all real numbers. This function is increasing on the interval from -infinity to infinity as long as my slope, m, is greater than 0. Slope greater than 0 means that the slope, this number right here, must be a positive number. If this number is positive, then this graph is going to rise as I look at it from the left to the right. The y values are increasing as I look at this graph from left to right. So we say this is an increasing function. However, if my slope is less than 0 means negative, so if this number is negative, then my graph is going to look different. It's going to slope this way. It's going to fall when I look from left to right. The y values are getting smaller from left to right, so the y values are decreasing. So we say that this function is decreasing on the interval from -infinity to infinity. That's all real numbers when the slope is negative. The next linear function that we're going to talk about is the constant function. The constant function is a function of the form f of x equals b. b is just any number. It is the y-intercept. The graph of a constant function is a horizontal line with a slope m equal to 0 and a y-intercept of b. Here's a picture of our constant function. As you can see, it crosses the y-axis at b. Whatever this number is where it will cross the y-axis. And if you look at the slope, it does not slant. It's a constant function. It goes straight across horizontally. So if I picked a point here and picked a point here and tried to count the slope, I wouldn't rise any at all. No rise over whatever the run is there. So 0 divided by any number is 0, which is why the slope is 0. Looking at the properties, the first one being the domain, I can pick any x and find a corresponding value for y, so I can say that the domain is all real numbers. However, if I'm looking at the y-axis, I can't pick any y. If I pick a y down here, there is no corresponding x value. If I pick a y here, there is no corresponding x value. If I pick a y here, there's no corresponding x value. The only y value that I can pick that will have corresponding x values is this value of whatever b is. And then I have infinitely many corresponding x values. So the range here is simply the number b. This function is neither increasing nor decreasing. As I look at it from left to right, the y value is not going up, the y value is not going down, the y value is staying the same. So we say that this function is constant on the interval from negative infinity to infinity, which is all real numbers. The last function that is a linear function that we're going to talk about in this video is the identity function. It's a function of the form f of x equals x. This is the graph of a line that passes through the origin, and it has a slope of 1 and a y-intercept of 0. This number that's not written in front of this x is an understood 1. That's the slope. And there's nothing added on the end, so mx plus b, there's no b being added out here, so the y-intercept is 0, which is why it passes through the origin. Here's a picture of the identity function. It does go through the point 0, 0. It also goes through the point 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2. Whatever x you put in is the same number that you will get out. So the x that you put in and the y that comes out is the same. So that's why it's called the identity function. The x you put in retains its identity when it comes out as the y. So let's look at the properties. The domain here is all real numbers. Like we've talked about before, for any x on the x-axis, you can find a corresponding y. The range is all real numbers because here, if I look at the y-axis, any y that I pick, I can find a corresponding x. This particular function is increasing. It's increasing over the entire domain of all real numbers from negative infinity to infinity because, this means because, that's my shorthand for because. It's increasing over all real numbers because its slope is positive. There's a positive 1 understood here. So it's increasing. The y's are getting bigger as we look at it from left to right.